Welcome to Assalam Tech. Today I will talk about GPS. What is GPS and GPS, how does it work? A really fascinating technology is GPS. It employs a constellation of 24 satellites that orbit the Earth continuously and demands a minimum of 4 satellites to find out where you are. It operates on atomic time, and the mobile phone's time zone inaccuracy is a significant risk as well. Furthermore, relativity theory by Albert Einstein had a significant impact on GPS technology. Lastly, a practical application for the relativity theory. Set aside all of these challenges and comprehend GPS technology is done in a systematic and step-by-step fashion. Assuming you have a mobile phone and your friend wants to know where you are, this includes a GPS receiver. An intriguing mathematical method used in GPS trilateration is a method for determining someone's location. First, let examine trilateration essentially in 2 dimensions. There must be at least 2 satellites to determine your position in the trilateration of 2 dimensions. By utilizing some engineering principles, the satellites use distance measurements between the satellites and you. Later, we will see the methods for doing this. Now everything is simple. Your location is known to the first satellite to be R1 away. So somewhere in this circle should be where you are. Your distance from the second satellite is R2, which it knows. Consequently, you two thought to be on this circle. This signifies where you are right now should fit into both of these spheres. In other words, you thought to be at the intersections. There is now a minor problem. There are 2 points of intersection. What is your current position then? You consider the Earth's surface to be the third circle for this and discard the unlikely answer. In the universe of 3 dimensions, you can adopt the same strategy. In this case, 3 satellites are required instead of 2. In the universe of 3 dimensions, the satellite is aware that you are on a sphere somewhere. Your position becomes more precise when a second satellite is used, becoming a circle. Take note that a circle results from 2 spheres intersecting. With the assistance of a third satellite, you will be able to focus on a certain area, merely 2 points. Here a circle intersection, likewise a sphere, yield 2 points. Like in the prior instance, Earth serving as the fourth surface, we discover the 3 special coordinates for the right spot. Let's check how far apart you are now. Also measured is the satellite. Each satellite is outfitted having an extremely precise atomic clock. The satellite transmits sporadic radio transmission to Earth. This radio transmission will include the satellite position and the precise moment it was sent. Assume the receiver is also equipped with a precise clock. The signal is picked up by the Earth's receiver. This image displays a standard smartphone GPS receiver. Considering that radio waves move at the speed of light, the signal is received by your receiver after a predetermined amount of time. By identifying the distinction between the timings of sending and receiving and dividing it by the light speed multiplier, you will be able to learn more. Your separation from the satellites. You have previously received the satellite's coordinate, thus you can create a sphere with ease. One thing to keep in mind is that the time measurement needs to be quite precise. Even a microsecond inaccuracy will result in an error. A distance in kilometers. Due to enormous speed of light, the key problem is now revealed. The clock in your receiver is not very precise. Your laptop or mobile device's effort on improving inaccurate crystal clocks contrasted with atomic clocks. A smartphone with an atomic clock is simply unworkable. It's simple to observe how incorrect when compared to an atomic clock. Your smartphone's clock, just looking at the clock settings, the disparity between actual time and what we call the as well as the time indicated by the timer on your smartphone. Due to the time difference, there will be an error in GPS calculations. How do we overcome this issue? The good news is that because all 3 satellites maintain the same time, your smartphone's time offset with each satellite is the same. The value of your device time of offset turns become the new unknown. This indicates that in addition to the 3 special coordinates, the time offset value has to be resolved also of your receiver. A second satellite measurement is required to address this fourth enigma, and for the reason we require 4 satellites to determine where you are. By doing this, we can do without an atomic clock in your smartphone. It will be obvious that at least 4 satellites can see your location at all times if you look at the present GPS constellation. Hold on, there's still more of this video to come. We still have a problem to resolve. Despite all of these cutting edge technologies, your location will not be accurate using this GPS system. The critical part now of relativity as proposed by Einstein, time is not constant. Numerous additional elements affect it. The theory of special relativity states that a clock that is ticking quickly will stop. This will cause the 14,000 km per hour 7,000 mph atomic clock to slow down by 7 microseconds every day. 20,000 kilometers above the surface of the Earth, 1/4 of the satellites experience gravity of the Earth. Thus, in accordance with the Einstein's theory of general relativity, the time will pass a little more quickly. In this instance, roughly 45 microseconds daily. This results in a net offset of 38 microseconds is built into the atomic clock every day. To make up for this, it integrates a theory of relativity equation into the chips in computer and modifies the atomic clock's tick rates without using the theory of relativity. In this way, the GPS would have resulted in a mistake. Every day of 10 km, the US Department of Defense created the GPS navigation system, which is available to everyone at no cost, but there are reliable substitutes accessible in many nations today. Modern receivers use both GPS and GNSS concurrently. An additional navigational aids to determine the most precise place. Now just a brief query: do you need an internet connection to use GPG? There is no need for a cell phone service or the internet for GPS, but with their assistance, GPS initialization can be made much faster. Satellite-based position data downloadable from the internet instead of the extremely slow direct satellite downloads. These GPS units are referred to as added GPS.